Welcome to this comprehensive guide on data persistence in C#, a crucial skill for any developer looking to save application settings and user progress. Data persistence is essential for enhancing user experience by allowing applications to remember information between sessions, making them more user-friendly and functional. Without persistence, users would have to re-enter preferences or lose their progress every time they close an application, leading to frustration. For beginners, several methods are available, each offering unique advantages depending on the type and complexity of the data you need to store. We'll explore these methods step by step, providing clear explanations and practical insights to help you choose the right approach. Let's begin by exploring the built-in settings file, a straightforward way to manage key-value pairs within your C# applications. The settings.settings file allows you to define properties with either user or application scope, controlling whether settings are specific to a user or shared across all users. User-scoped settings are stored per user profile, ensuring personalized experiences, while application-scope settings are read-only and common to all users. Accessing these settings is simple through the Properties, Settings, Default Object, allowing you to read and write values directly. Remember to call Properties, Settings, Default, save after modifying user-scoped settings to persist your changes to disk. This method is ideal for simple configuration data like theme preferences or default window sizes, offering easy access and modification. However, it's not suitable for complex data structures or sensitive information due to its basic key-value pair nature and lack of encryption. Next, we'll look at INI files, a human-readable format often used for configuration settings due to their simple structure. INI files organize settings into sections and keys, making them easy to understand and edit manually, even without specialized tools. For example, a section named Database might contain keys like server and port with their respective values. While C# doesn't have a built-in INI parser, various third-party libraries can simplify reading and writing these files. These libraries provide methods to easily retrieve values by section and key, abstracting away the file parsing complexities. INI files are great for simple, human-editable configurations, but lack strong typing and can become cumbersome for very large or complex data sets. Moving on, XML configuration files offer a more structured approach, especially for complex application state management. The .NET Configuration Manager allows you to manage these files, making it suitable for storing data like window dimensions or database connection strings. XML's hierarchical nature provides excellent organization for settings that require more than simple key-value pairs, such as nested configurations. You can define custom sections and elements within your XML configuration, allowing for highly specific and extensible settings. While powerful, XML can be verbose and less human-readable than INI files, often requiring programmatic access for efficient management. JSON serialization is a highly flexible method for handling complex data structures, widely used in modern applications due to its lightweight nature. Libraries like System, Text, JSON, or the popular Newtonsoft JSON allow you to easily convert C# objects to JSON strings and vice versa. This process, known as serialization and deserialization, enables you to save entire object graphs, including nested objects and collections. JSON is particularly useful for saving game states, user profiles, or any data that benefits from a structured, yet easily readable format. Its human-readable format also makes it convenient for debugging and manual inspection of saved data. When working with JSON, consider using attributes like JSON property to control how properties are serialized, including custom names or ignoring certain fields. For minimal data, flat files, either text or binary, offer a direct way to store information without complex formatting. The System.io namespace provides all the necessary tools for reading from and writing to these files, giving you fine-grained control over the process. You can use StreamWriter and StreamReader for text files, or Binary Writer and Binary Reader for binary data. Text files are human-readable and easy to implement for small, simple data sets like log entries or basic lists. Binary files, while not human-readable, can be more efficient for storing raw data types and can offer a slight performance advantage. While simple, flat files require careful management to ensure data integrity and prevent corruption, as there's no inherent structure enforcement. For complex applications, databases like SQL Server or SQLite provide robust solutions for structured data, ensuring consistency and reliability. Relational databases organize data into tables with defined relationships, offering powerful querying capabilities and data integrity constraints. Entity Framework simplifies interaction with these databases, offering an object relational mapper that streamlines data access by mapping database tables to C# objects. With YEF, you can perform CRUD operations on your database using familiar C# syntax, reducing boilerplate code. Databases ensure data integrity through transactions and constraints, provide scalability for growing data, and allow for complex queries. They are the ideal choice for applications with large amounts of structured data, multi-user access, or strict data consistency requirements. If you're developing in Unity, PlayerPrefs offers a simple, built-in solution for storing small amounts of data like user preferences or high scores. It functions as a basic key-value store, making it quick and easy to save and load simple data types. However, PlayerPrefs is not secure, as data is stored unencrypted, and it's unsuitable for large datasets or sensitive information. Always consider the limitations of PlayerPrefs before using it for critical game data or anything requiring robust security. Saving user progress effectively requires a thoughtful strategy, combining the right persistence method with clear data structures. For instance, a game might use JSON for complex save states, a database for player inventories, and PlayerPrefs for simple settings like volume. Design your save data structures to be modular and extensible, allowing for easy additions or changes as your application grows. Consider implementing incremental saves for large progress data, saving only changes rather than the entire state each time. This can significantly improve performance and reduce the risk of data loss during unexpected interruptions. Now, let's discuss best practices for data persistence to ensure your applications are robust, secure, and user-friendly. Security is paramount. Always encrypt sensitive data, especially if it's stored in easily accessible formats like flat files or PlayerPrefs. Use strong encryption algorithms and securely manage your encryption keys to prevent unauthorized access to user information. Implement versioning for your data structures to handle changes gracefully as your application evolves, preventing compatibility issues. This ensures that older saved data can still be loaded and potentially migrated to the new format without breaking the application. Thorough testing of your saving and loading mechanisms is crucial to prevent data loss or corruption under various conditions. Simulate various scenarios, including unexpected shutdowns, power outages, and disk-full errors, to ensure your persistence logic is resilient. Consider user experience by providing clear feedback during save and load operations, such as progress indicators or success messages. This reassures users that their data is being handled correctly and prevents them from prematurely closing the application. Always back up critical user data, especially before major updates or migrations, to safeguard against unforeseen issues and data loss. Choosing the right data persistence method depends on your application's specific needs, balancing complexity, security, and performance. For simple settings, the built-in settings.settings file is often the most convenient choice, offering quick and easy access. INI files offer human readability for configuration, while XML provides structured storage for more complex application states and extensibility. JSON serialization excels at handling intricate data structures, making it a versatile and modern option for various scenarios, including game saves. Flat files are suitable for minimal data, but require manual handling for integrity and security, making them best for very simple cases. Databases, coupled with Entity Framework, are the go-to for large, complex applications demanding high integrity, scalability, and multi-user support. Remember PlayerPrefs for Unity-specific small data, but be mindful of its security limitations and avoid using it for critical information. By understanding these methods and applying best practices, you can confidently implement robust data persistence in your C# projects. This knowledge empowers you to create more dynamic and user-friendly applications that remember and adapt to their users' needs. Keep practicing and experimenting with different techniques to find what works best for your specific development needs and project requirements. Thank you for joining this comprehensive tutorial on C# data persistence. Happy coding!